what I like to do today is introduce to you the Huawei public cloud FPGA accelerated instances. I'm sure a lot of you in this room know about Huawei does the phone devices, right? We're pretty popular in Europe. We're actually the #2 smartphone provider now in the world by volume shipped. We're ahead of Apple. Some of you may even know that Huawei actually does a lot of the telecom infrastructure as well. So we do everything from the antennas, all the computing equipment from the antennas, all the way back to the backhaul, all the way to the data centers. That's also Huawei business. Many of you probably don't really know about Huawei's public cloud business because that's largely based in China. So I want to get introducing you all to Huawei public cloud and then go into our FPGA instances. So just about me, as Vinay said, I'm actually a principal hardware architect at Huawei, and I've had a great pleasure of running a team that's helped do the SDXL based shells for Huawei public cloud. About that public cloud, well, it's predominantly based in China, right? That's where the Huawei branded public cloud is. So if you can see there on the slide, we actually have 5 major data centers across China, plus we have 30 city nodes. And there's 95 cloud services that are supported across all of these sites. And they're all connected with a high-speed interconnection network. In fact, the major DCs are the ones that have the high-speed network connection. And we target, in fact, certain scenario solutions. So data warehousing, IoT, cloud, all of these are targeted scenario clouds where these different cloud services target underneath. What we actually did back in September now, end of September, in Shanghai at the Huawei Public Cloud Conference, is announce the FPGA instances. So those are actually part of the compute service there. And those launched with a beta program. We call the instances FP1, and it's part of something called FACS. So I could make a terrible joke about just the FACS, but really it stands for FPGA Accelerated Compute Service. So not only do we offer these instances, or rather do we offer cloud solutions in China, but we also have some cloud partners. So Huawei itself, as I mentioned before, we have the phone business, we have the telecom business, and then we have the cloud business. Well, the cloud business spun out of our enterprise business. So Huawei sells about 70% of the market share of servers in China. It sells a huge amount of the storage solutions, and in fact, globally, it sells a lot of storage solutions. But what it also started doing is rolling up cloud solutions to its telecom partners. So in fact, even here in Frankfurt, we work with T-Systems, and T-Systems has something called Open Telecom Cloud. So they provide infrastructure as a service and platform as a service solutions, for compute and network. And it's quite exciting to be able to say that the FACS FP1 instances will be coming. We expect those to be rolling out in Q2 of this year in the Open Telecom Cloud as well. So an interesting thing about Huawei, again, is we have a public cloud, we have public cloud partners, and we have these enterprise solutions. So not only do we really have the FPGA instances, but we also have the ability to sell the FPGA platforms for on-premise. So that's quite exciting for anybody who's looking to do, hybrid scenarios where they would be doing something on-premise and then something with one of our cloud partners. So what do you get with our FPGA as a service? Well, really, this is a whole solution, right? So this comes bundled with everything from the images themselves to the development environments on those images, so things like Vivado and SDXL. And then, of course, we have a marketplace where you can go and you can publish any of the IP or any solutions that you've created, and you can deploy these on the FP1 hardware instances. So we are trying to offer a complete solution with HDKs, SDKs, and marketplace. What can you do with these FPGA instances? Well, this is a room full of expert users, right? So I think I'm preaching to the choir a little bit. But there's a lot of things, obviously, that can be accelerated with FPGAs. And you can be designing new services. So, you could be doing CFD modeling or CAE modeling with these devices. They're very good for numerical computing in general. And not just, say, CFD side numerical computing, but financial analytics as well as another key workload. You could be running analytics cases, so again, risk analytics, or you could be doing AI-based applications. As we all know, machine learning is a very hot topic for FPGA acceleration right now. And then likewise, this feeds into developing these intelligent solutions for life. So again, there are lots of things to do with predictive analytics and AI with big data solutions all feed into workloads that are usable on FPGA. So I'm stealing a bit of good benchmarking from our partner Xilinx. Why you would want to use these instances, obviously, is the performance benefits. So between Xilinx and ourselves, we've published a number of different benchmarks, but for a given set of workloads like machine learning, there are things like 13x speed-up improvements, 50x for data analytics, and 30x for things like vSwitch, OVS offload scenarios. So there's lots of good application scenarios that see really good performance benefit. And this, by the way, when we're looking at those numbers there, that's just performance improvement. The other neat thing about the cloud, as a lot of you I'm sure are coming aware of, is it's a utility model. So if you're not spending $6,000 or $8,000 on a card and taking 2 months to develop an environment, if you can get onto it and pay for a few hours and maybe $100 later or so you have a working application accelerated, well, the performance per cost benefit is substantially better. So one example of this would be H.265 transcoding. This is a case where we have a file playing back. It's actually a Huawei promotional video. But on the left-hand side, there, your left-hand side, we have an FPGA instance. On the right-hand side, we have a CPU instance. So this is a S1 that you can get on Huawei Cloud versus an FP1 on Huawei Cloud. And the FP1 and that 2x large is one FPGA. And that one FPGA is actually has the ability to run 4 H.265 streams. We're only running 1. And in that one, we're running at 60 frames per second, whereas the CPU one, you can see the CPUs are fully maxed out, 100%, 6 vCPUs, and it's running 6 frames per second on the transcoding playback. So it's a substantial gain here, right? A 10x gain. Look at the CPU utilization on the FPGA instance there. It's on about 25% on average. So it's a very compelling case. Another interesting case, and this was a demo. It took us about 2 months to make the demo, and we showed it actually live at Huawei Public Cloud. But here we're just showing the video playback. But it's gzip compression, right? So we see a 5x speed up, same comparison, single FPGA instance versus a software instance with 6 vCPUs. And here we started with 3 files, gigabyte files. And for that particular case, the FPGA finishes with, again, around 50% CPU utilization, whereas the CPU one is completely throttled, trying to chug away here on compressing the files. So, and the nice thing about that particular example is we did 3 files and then we did 10 files, and you could see the linear scaling on the FPGA because of the way the gzip engine maps to the hardware. So there's lots of good demonstrable cases for FPGA acceleration, and again, where cloud just enhances the benefit of it through the cost model. So I wanted to touch on why Huawei. A lot of you in the room here are thinking, okay, well, I'm in Europe, and you're talking about a public cloud predominantly in China, and you do have these partners in Europe, but why do I care? Well, mostly in this room, I'm sure we have a lot of potential partners, and we're really interested in inviting you to come and access the Chinese market, as well as access our telecom partners in China, or to go and use our on-premise solutions, buy the platform, buy the FPGA from us. But what do you get as well with Huawei as a partner? Well, Huawei's been doing, telecom-based FPGA solutions since 1995. We then moved on to NFV-based acceleration. So previous to working on the public cloud instances, even our team in Toronto, we had the benefit of working on a COTS-based solution incorporating FPGA acceleration. But we're only one little team. There's actually lots and lots of teams doing FPGA engineering at Huawei. In fact, we're one of the leading providers, if not the leading employer, rather, of FPGA engineers for companies around the world. Maybe these days AWS will be changing, but they do it through their partners. But we are the largest employer of FPGA engineers. And that's a history, obviously, from 1995. So we number in about the thousands of FPGA engineers. So that's an impressive history built up of IP knowledge, of platform knowledge that partners can leverage, right? So anybody looking for technical collaboration for new shells, for example, Huawei is a value-add partner for that. What exactly do these instances look like? Well, they'll look pretty similar to anybody who's used the F1 instances on AWS. The card itself is a VU9P based card. And likewise, we have mesh interconnects. What's a little interesting and different about us, you'll notice that there is a 100 gig E, that's actually a dual stack 100 gig E interface on the front panel. So this opens us up to some opportunities to look at inline acceleration, so network acceleration cases that would be interesting for partners to do and leverage. And likewise, the mesh allows you to do the high-speed serial links between the FPGAs. So we have the same benefits as other platforms, but this other added benefit where we could offer network acceleration solutions. In terms of the instance configuration, you'll see that there are really three instance flavors here. One, the first one where you get a single FPGA, and that comes with 8 vCPUs and the 116 gigs of memory. And then we have a by 4 FPGA instance and a by 8 FPGA instance. So those are the three variants of that. So you can deploy this in a way where you can change the configuration for whatever the right cost to performance benefit is for your application. The other thing I think is a nice touch, obviously, is the NVMe-based storage. So this is SSD-based storage. It's high performing. And the thing about the instances in general and the rest of the Huawei Cloud features is there's a lot of performance being put on the table. And I encourage people to go and look Huawei Cloud, huaweicloud.com up to see a lot of the other instance configurations. Because when you go and develop and deliver an FPGA accelerated solution, the FPGA is only one part. You're going to incorporate storage, or you might incorporate a virtual private cloud. So all of these services become important and are available there. So what does the development environment look like? Well, we offer, Xilinx is a very valued partner of us, and so we do offer an SDXL-based shell, and our images come with that development environment in there, and as well you can use Vivado. We also provide a professional simulation platform. I'll get into a little bit about that in a later slide. But we actually do offer two shells. There's the SDXL shell, and we're really targeting in that, one, being in the Xilinx ecosystem, which is critically important. But two, it's really there to enable fast, easy development. So this comes with all the productivity features Xilinx already builds into it, but as well, you get the benefit of the time to market for it. The other shell we offer is a DPDK, what we're calling a DPDK-based shell. So that's actually a DPDK-based runtime. And I don't know who's familiar with DPDK in this room. A few people. Okay, great. So at least there's 4 of us. So DPDK is actually a packet processing framework that Intel originally developed to bring network cards closer to the CPU. So it's a highly optimized framework. It allows lots of things like CPU pinning, memory pinning, huge tables, and that's just in the runtime. Well, what we've done in the FPGA itself is the DMA engine is a network-based DMA engine. And I'll get a little bit into that in the next slide. So both of these are offered in these environments. So here's the two shells if you want to look at it a bit closer and do a comparison. Again, the SDXL, it's there for rapid development. It's a block computing model because it's a scatter-gather-based DMA engine. But with a DPDK-based shell, we're offering a queue-based ring buffer DMA engine. So this will allow, you don't have to use it for packet processing. In general, it'll allow a 12 gigabyte per second throughput. It'll hit a line rate, if you had a 40 gig NIC, for example, although we have 100 gig, but you would hit the line rate of 512 byte packets frame. So both shells offer benefits. One is going to be easy to use to start porting to. The second one is highly performant. It will take more time to develop for, just to be clear. So about the simulation platform, in this case, because Huawei has these many years of experience, we actually have taken a lot of the framework that we've used in-house over years and put that into a professional suite. So especially if you're going to be using the DPDK shell, and let's suppose you're not integrating HLS kernels into it, but you wanted to integrate RTL kernels into it, and then you wanted to functionally verify those kernels. Well, what we're offering to you in the simulation platform is the ability to do this through all the different tools that we support. So this will include System C verification, UVM, System Verilog, and you can see all the features here in terms of the simulation models that we've built already for you to use. There is a stimulation generator for you, so you can define your test benches, test cases, and feed this in. So a lot of these IP blocks are there ready for you to use to get productive on the verification environment. So if you prefer an RTL-based flow and you want to do functional verification this way, these are all professional tools that are provided to you. In terms of the use cases, we have quite a few partners that are right now in our beta program in the Huawei public cloud in China. And I wanted to highlight for you guys today two partners in question. The first one being Falcon Computing, and the second one being CTXL. So Falcon, as many of you know, are actually an HLS development tools provider. They do a compiler called Merlin C. So they do C-based HLS kernels. And they do an equivalent to an OpenCL runtime, which they call Kestrel. But what Falcon then does on top of these tools is they build specific solutions for given customers. So right now on Huawei Cloud, they're working with a particular customer in the genomic space. And what they do is they take this Kestrel runtime and they integrate it with, well, what they call their Falcon genomic solution. But what that actually is they support the existing libraries that are available. So this will bind with GATK. So if you can see in the little infographic up there, if we were doing the genomic analysis stage from GATK from GA2 toolkit, then this would integrate and accelerate things like the pairwise hidden Markov modeling. This could accelerate the Smith-Waterman modeling. This would accelerate before that from the Burrow-Wheeler's transforms, and will do a lot of the alignment sequencing acceleration. So they'll work with that toolkit. They'll work with Blazor if you were using Blazor for the alignment sequencing, and they offer this as a solution. They work with customers on Huawei Cloud. So what that looks like on Huawei Cloud is they're really offering this accelerator as a service. They integrate into the GATK, and then they use a combination of RTL kernels and Merlin C generated kernels. This is all obviously targeting an FP1 instance, and the FP1 they're using is the single FPGA instance. And they'll actually launch a few of these instances, given whatever the given customer set is. So they'll scale out those instances. And then the customer's genome map sits on top. And the customers they work with, they are not FPGA people, they're genomic sequencing people. So they're abstracting away the details of this through the agreement really is the GATK, for example. That's the agreement between them and the customer. So they're running a successful program right now with a few customers. And the other interesting case here is CTXL. So CTXL, they're an image processing company. And what they're known for is really image transcoding. So this is where you would take from one format to another. So in particular case, they do JPEG conversion to WebP. And the reason they do that is if you look at a Google or if you look at Facebook, you know, if you imagine on your phone, if you've got like Google Photo Assistant and you're uploading your photos to the cloud, and then what happens is you're going to get your items indexed on here, right? Everything gets indexed and you get a thumbnail image. So what you'll do at that point is you're going to take the raw JPEG image, and maybe that's, you know, a 1 meg file, but you're going to produce a thumbnail and you'll do it in a new encoded format, which is WebP. Google brought that out, I think, a few years back. And they'll do the conversion in the back-end cloud and then serve back the thumbnail. So they do this for a number of partners, right? You can imagine any online store you go to would use this. The photo assistants would use this. CTXL have been doing this for cloud providers and for online retailers in China. And we're excited because for them, obviously, they need to scale out to multiple data centers. They need to have an ability to do disaster recovery or, you know, spike up based on demand. So they'll use a number of cloud platforms. So they will take their customers' media apps, and typically these might be things like storage, where the customer rather needs a big storage solution on the cloud where they're storing, say, the photos. And then they'll extract the images from there, run the transcoding, produce back the WebP thumbnails, and then serve that up either to edge devices or back into the cloud. So the way their solution works is they really integrate again into a common library, an existing library. So they use ImageMagick software, and they use OpenCV for this. And then underneath, they're working with the Huawei and Xilinx SDXL shell. So that works with OpenCL runtime, with our SDXL XDMA-based shell, and then they put their image transcoding IP in the FPGA there. So this company is quite interesting because, again, their benefit is it's actually 5x. And a lot of you in the room might say, well, that doesn't sound that substantial. But if you're actually a large provider of such a photo service, 5x can be quite substantial, especially if these instances are very cheap to buy and run. So the TCO reduction, often they can see a 50% reduction in TCO as a result of doing this. So both of these partners, you know, are good cases to highlight with respect to Huawei Cloud, because they both have innovative solutions that serve, you know, real product demand. In fact, Huawei is building up its ecosystem, right? And again, that was one of the pulls to come here, is to invite, you know, partners, potential partners in this room, to come and check out Huawei Cloud. And if you don't have China market access right now, this is one of the key things you can get with Huawei. So we already have a lot of different partners, such as CTXL, eElements. They're a training company, so they do application examples or training courses for different companies for FPGA. We have DeFi, and I think DeFi is actually in the edge track right now, because DeFi do both, they do soft DPUs for edge devices and ASICs, plus they're doing soft DPUs for the cloud. So they'll do this for inference-based applications on the cloud for image processing, for example. So DeFi is a partner we're really interested in, and especially because of the deep learning case. We also count NG-Codec as a partner in our beta program right now, and I think you heard a lot about them from Gadi's talk earlier. So they focus on video transcoding cases for anything for broadcast, I think, is one of their biggest ones. And then likewise, of course, we have Falcon as a partner. But in terms of partners, we're looking for people who can provide acceleration IP, people who are design service providers. We're looking obviously for end users, just being a customer is great. And also solution providers and domain partners. So, if you have a solution integrated into Elasticsearch or, a given stack, then you would be a great partner to come into Huawei Cloud. Likewise, Huawei sells and makes a lot of IP, so we're continually putting our IP into the marketplace for this. So not only can you get the images and you can get the engines, but you can also get the IP cores to integrate that into your designs. And likewise, you can go to GitHub. You can get the projects off of there. The development tools, the HDKs and SDKs are all available through that. The developer ecosystem, well, we're focusing on making open source solutions on education training, and also through a university program that we're running in China. In fact, we're going to be tying into Xilinx education program as well. But again, just to focus on the bottom of that stack, not only do the instances happen on Huawei Public Cloud here, but Huawei will sell these to third parties. So again, here in Germany, that's T-Systems. And then likewise, we sell the cards for on-premise sale. So that's really my last slide. What I would like to do before I go, though, is invite you all to check out the beta program. I had my details. It's craig.davies@huawei.com. So please send me an email if you're interested in joining the program, or find me after the talk. I'd love to talk to you outside. Thank you.
Any questions for Craig?
Off scot-free.
Okay. Oh, there is a question.
Oh.
I was interested in the slide where you have Nvme connects.
Mm-hmm.
So that sounds quite exciting. So you got access to very large storage devices on the end of that, is that right?
Yeah, that's correct. The instances itself are actually configured with that. That's the local storage. So we do have like a storage service as well, but this is all the local scratch storage effectively.
So does the Xeon have access to that as well? Is it shared?
Yes.
Or is it private to the FPGAs?
No, it's not private to the FPGA.
Okay. And is it shared between all the instances?
So each instance that's configured, so this will be the FPGA that's attached to, say, the 8 vCPUs, that will have also the 800 gig storage. So yeah, in the case where if you're asking if I have a 4 FPGA configuration or an 8 FPGA, then that storage is shared across the 4 instances there.
Okay. So just as, sorry, so as a use instance, you could upload a huge amount of data to the Nvme storage, yeah, and then process all that on the FPGAs without touching the network.
Correct. Yeah.
Yeah, that's good. And do you provide the Nvme IP?
Well, no, there's no Nvme IP into the FPGA right now. Yeah, that's a great idea.
Yeah.
Let's talk.
Yeah.
So I just wonder how the 10 gigabit Ethernet network hooks up to the FPGA and the use cases for that.
So I'm just going to try and repeat back your question. You were asking about the inline ability, so the QSFP28's on the board?
Yes.
And you were asking...
It says 10 gigabit Ethernet there, so I just wonder how
right.
that ties in.
So that 10 gigabit Ethernet is the Ethernet coming into the server itself, right? So that's the data network right now. The QSFP28s that connect directly to the FPGA, and the beta program, those are not actually active right now. Because one of the things we'd have to work out with partners who come in who are shell providers, sorry, I'm just going to click over, is we need to work out how the network security is going to work, and we have to trust and certify the shell partners. So for that particular case, we're looking for partners who want to come in and develop that IP. So if you look at this picture here of the DPDK shell, there is a grayed out box, which is the NIC and the Ethernet. So that's IP we kind of have ready sitting in the wings for when a partner wants to come in and take advantage of this solution. Yeah, but that's basically a capability that we'd need to leverage with a partner.
Cool. Thank you.
No problem.
Do you have an example use case of the Huawei DPDK-based shell?
An example use case of the DPDK-based shell? There are a couple cases that are happening in the Huawei public cloud beta now, but I can maybe generalize because I can't necessarily share sensitive information. But for the DPDK-based one, if you go to intel01.org, you'll see a lot of different application examples. And a good intuitive one is the IPsec gateway service, right? Now, the version they do is overly simplified, but the idea with that, obviously, is that the IPsec tunneling service would have been implemented in a DPDK software layer. Now, what you could do with this version is you could actually take the IPsec encryption IP, and typically they would do that as an offload to an accelerator. So the x86 will have crypto accelerators, right? But the thing is, you're still paying the Turing tax of going over PCIe to these devices. So what you want to do instead is do an inline version. So with this ability of having the network port, you could implement an IPsec gateway, implement the encryption IPs in the FPGA, and do the level 3 and IPsec packet processing all on the FPGA, right? So that's an example where the DPDK shell would really shine for a network use case, for example.
Right, but I guess that would require the NIC to be connected.
That would require the NIC to be used. But to be fair, so to go back to an offload case of it, because it's Q mode based, and because it has very low latency and high throughput, so throughput again is about 12 gigabytes per second, even for offload cases, it's a really optimal solution, right? So the I/O bandwidth coming off of it, and again because of the polling, the latency is very low between the software to hardware transfer of notification events. So, so any of those other block computing cases would still map well to this.
Any more questions? Okay, great. Hey, thank you very much, Craig.
Thank you.